So you've been presented with this problem. We have a nice clean river that's flowing by a waste lagoon that's discharging that waste into the lagoon. And we want to know what the concentration is going to be of that waste downstream, considering that we have flow coming from upstream and then discharge into the stream at about this point right here. This is actually a pretty practical problem, and one that gets solved by hydrologists and engineers all the time, because often the regulations say that there's a maximum concentration of something downstream that's regulated. So in our example, that's chloride, but often it could be other stuff. It could be nitrate, it could be biological discharge. It depends on what's in the waste stream. So that's what we're after. We want to find that CD. And we're told that the lagoon discharge is 3 cubic meters per day, and that the concentration is 2 grams per liter. We're also told that the concentration of chloride upstream is 0, but we know that the discharge in the stream upstream is 57 cubic meters per day. We don't know this, and we don't know this. This is ultimately what we're after, the concentration downstream. So what do we know? We have volume balance, and we have solute balance. So our volume balance is simply the flow upstream plus the flow from the lagoon is equal to the flow downstream. Our solute balance is going to be the flow upstream times the concentration of chloride upstream plus the flow from the lagoon plus times the concentration in the lagoon is equal to the flow downstream times the concentration downstream. And again, this is what we're after. So before we start jumping into solving this, which we know from using our old and our new water, we could probably solve by substituting the volume balance into the solute balance. Let's take a look at this concentrations. Upstream, the concentration is 0, which means that this term is 0. So then it means this whole term is 0. And so our solute balance is actually quite simple. Excuse me. So our concentration downstream is the concentration in the lagoon times the flow rate from the lagoon, excuse me, divided by the flow rate downstream. So we're given the concentration in the lagoon. We're given the concentration in the lagoon. We're given the flow rate in the lagoon. We don't know the concentration downstream, and we don't know the flow rate downstream. However, we can find the flow rate downstream because we have that term right here. So now we can solve by plugging in the variables that we have. We have the concentration downstream is equal to the flow rate from the lagoon times the concentration in the lagoon divided by the downstream flow rate, which we have from this equation. So we can use the flow rate upstream plus the flow rate from the lagoon. And now we have everything we need. So we know this flow rate, this concentration. We have both these flow rates, so we can solve for the concentration downstream. So all we have to do is plug in those values. And let's see, the flow rate from the lagoon is 3 cubic meters per day. Concentration from the lagoon is 2 grams per liter. The flow rate upstream is 57 cubic meters per day. And the flow rate from the lagoon is 3 cubic meters per day. And so we calculate that out, and we end up with, let's check the units, of course. So we have the cubic meters on the top, cancel out the cubic meters on the bottom. And we have days on the top, they cancel out the days on the bottom. And so all we have left is grams per liter. And so we should end up with 0.1 grams per liter. And if we multiply times, and we don't need to, but often we like to work in milligrams per liter, we have 1,000 milligrams in 1 gram. And so we end up with 100 milligrams per liter for our downstream concentration. And that is what we would report to the authorities to tell them that that's the impact that we're having on the stream. So the concentration that was originally 2 grams per liter is now diluted down to 100 milligrams per liter. Hasn't gone away, but often you can get away with dilution under environmental regulations.